Good morning. Today I want to do a short video before we get going into class today about how to divide radicals. So I'm going to flip my screen around here and give you a quick little crash course into it. So here we go. Right. So when you're dividing radicals, oh gosh, give me just a second here. Let me get this squared away. All right. When you're dividing radicals, you can actually look at this in a couple of ways. Here, I look at this and I see how both of these are under the same radical, 160 and the 5. And these numbers, because I ends in 0, that's 5, I know these are, 5 is a factor of these two numbers. So I can look at that and I say, okay, all right, so what is 160 divided by 5? That is 32, right? So I got the square root of 32. Square root of 5 goes down to square root of 1, which is just 1. So what I really have is 12 square root of 32 over 2. Now, this 2 and this 12, they can be reduced. So that's 12 halves. So that goes down to 6, and that's just a 1. So really what I'm left with is the square root of 32. And just from our other lesson, we've learned how we can break that down to say, okay, that's the square root of 16 and the square root of 2, which is 4 radical 2. So your takeaways here. Here's what you should look at. Look at this, make sure they have the same index number, of course, which they do. And look at the two numbers underneath. If you can reduce them like that, that could greatly simplify this type of problem for you. So those right there could simplify. So it went down to square root of 32 on top, square root of 1 on the bottom, which is really just 1. Numbers out here in front, like the 12 and the 2, these can be reduced. That's like saying 12 halves. So, truth, I could have done it earlier than problem, but I waited just a second before I did it, so I did it right here. So little tips like this can help out a lot. So especially with something like this. Ooh, Nelly, look at that. So let's start with the numbers in front. The 36 and the 9. Well, I know at 9 we're going to 36 4 times, because we know our basic multiplication facts, right? So I have 4, the 4th root of 1250 all over the 4th root of 2. All right, now be careful. This 2 right here and that 4 we cannot do anything with, so don't try to do that. But the 1250 and the 2, well, that's the even number, so I know 2 is a factor of it. So 1250 divided by 2, 625.
But I need the math team to the front lawn, please. Math team to the front lawn.
They never miss an opportunity, do they? So that goes down to 625. That goes down to 4th root of 1, which is just 1. So that's really over 1, but I'm not going to write that because we know that. All right, so 625, the 4th root of 625 is 5. Yeah, it's 5. So this breaks down to just simply 5. That worked out very, very pretty. That doesn't always happen. Sometimes you end up with some still weird looking radicals. That's okay though, nothing to worry about. Let's take a look at this one. So I look under here and I say, okay, 7 and that's 64. Is 64 at all, will 7 go into it? And it doesn't. X to the 5th, y to the 6th. Now this has got a cube root here. So here's what I'm going to do. I'm going to separate this like this. I almost forgot my cube there. Don't want to do that. Okay, so now in our lesson yesterday, especially if you were in class, I kind of showed you how to handle something like this. Now, I was using square root at the time, but this time I'm using cube root. So I'm going to break this apart. Okay, and then I got the cube root 64 times the cube root of y to the 6. And what I showed you, and now I'm going to come over here to my margin and show you. I'm looking at this and saying, all right, so this is a cube root. How many times can I write x cubed multiplied by x cubed to get x to the 5th? And that's going to be x cubed times, well, I'm not going to get another cube out. It's going to be squared because, remember, 3 plus 2 is 5. Now, the reason I'm doing this is because what I showed you yesterday is that when the index number and the exponent number, when they match, that's kind of like, say, if I had like this right here. The cube root of x cubed is simply x. So what I want to have here is I'm going to have x on the outside, a cube root, and that x squared is still going to be inside the radical because the 2 was less than the 3. And likewise, I'm going to do the same thing for the y to the 6. So I'll come down here on this part of my margin here. So y to the 6, I can write as y to the 3rd times y to the 3rd. So that's going to be one y that clears the radical. And I have another y that's going to clear the radical. So this will become just simply y squared. Not under the radical, just y squared. So here's what we got. Let me drop all this down now. So I've got cube root of 7. Okay, so now this right here, the x cleared, so I'm going to put it outside here. The x squared never made it out, so it's still under the radical. Over, all right, now the cube root of 64. I believe that is 4. Yeah, I think so. So this breaks down to 4. The the cube root of y to the 6 was just y squared. So I got y squared here. So now here's one way you can tell that you're done. You don't see anything like they can reduce. So like this x and y squared, that ain't working because it ain't the same thing. But let's say I had like I don't know, say a 20 out here. You know, the 20 and a 4, you know, those are factors of each other, so those can actually reduce. Then we look under the radical. We make sure there's, say, cube root of x squared. No, that's as far as it goes. Cube root of 7, that doesn't break down, so I know that's finished. And then finally, this is probably the most important thing, which I'm about to illustrate over here. We don't want a radical in the denominator. So I don't have that. I know this problem's finished, so I can just box it and I'm done. All right, number 4 here. Look for stuff like that, like say like if that 3 had been say like had been a 4, and that 2 there. Now that's something that can reduce, but in this case I don't have that. I don't have that option. So what I'm going to do here is I'm going to do what's called.
Pardon the interruption, but I need the fishing team to the front lawn, please.
Sorry, guys. I'm going to do what's called rationalizing the denominator. What I'm going to do is I'm going to multiply both top and bottom by square root of 5. Not the 2, just square root of 5. Okay, so multiply straight across, you got 3 radical 5 over 2 times radical 5 squared, because radical 5 times radical 5 is radical 5 squared. Well, we know good and well what happens here. The radical sign and the squared cancels, leaving me just this, which is 3 radical 5 over 10. I know I'm done if the like that 3 right there and that 10, if they cannot reduce and nothing under here like it can be broken down, that's how you know you're done. And by virtue of the fact that there is no radical down here. That's the whole point in the rationalizing the denominator. Whole point in it. So I hope this video helps. I mean, now everything, let me turn my screen around here. Everything that we do in the dividing these radicals, they all hinge upon this one theory. Now there is some that maybe I'll come back, I'll talk about later, because I think I'm running out of time here, but I have to get started with class. There are some rationalize the denominator where you got to actually do what's called a conjugate. Not very hard. It's just one extra little thing to consider, but it's actually pretty easy. Conceptually, it's all the same. Just that conjugate thing. Maybe I'll do a separate video here in a minute, or whenever I get time to explain that. It might be at the end of the day, so you might see like bags under my eyes or something like. So, hope this helps kind of get you going on that, and happy studying. Don't forget to subscribe.